Hello, BSidesNYC New York. Hey. Woo! It is 4 o'clock. You guys have made it this far, and you guys are in for a treat today.
So if you want to know about what I consider to be the most underappreciated and I think least understood method of post-exploitation and possibly even initial access in Azure and M365, you're in the right place. If you don't want to hear about that, I don't know, go somewhere else, I guess. But what I want to start off with is a little bit of a story. So it is October 11th, 2024, like a week ago. A week ago as of today-ish, in the Huntress research facility somewhere in the far north. Not John Carpenter's The Thing. It's not the same. Why would you even recommend saying that would be the same thing as John Carpenter's The Thing? A group of the Huntress researchers are staring at this. And this doesn't look like a lot, unless you've been staring at it a lot in recent history, right? So in particular, one thing, after just looking at a graph that looks like this over and over and over again, one thing started to stick out. And that is this right here, right? So enhance. So this graph, and shout out to anybody that has used Bloodhound or Neo4j, because that was a big inspiration for why we built this. This graph caused 6 researchers at Huntress to almost fall out of their chairs, right? Okay, now why was that? Again, this doesn't look like much unless you've been like looking at this over and over and over again. You probably don't really understand what the graph is actually depicting, but I'm going to walk you through what we're actually looking at here. So again, 6 researchers, myself and Christina included, fall out of their chairs when we see this, right? And this is the exact thing that we saw that made us fall out of our chairs. Why is that? Well, when we looked at the data that underpins that graph, we saw a couple of interesting points, right? And again, this is just raw JSON output. It doesn't really mean much unless you've kind of been associating and working with this data, right? So let me walk you through it. We have the data for an M365 tenant, right? So just a Huntress protected, a Huntress partner M365 tenant. And that tenant has an application installed in it. That application is named ... 8 dots, right? That application has a credential object installed into it as well. That credential object is named ... 5 dots. 8 dot name, 5 dot credential object name. And it doesn't even stop there, because that's kind of interesting, but that could be just like an M365 admin messing around or something like that. But what we then found is that this application has delegated access to the permissions that allow an application to access the email inboxes of one particular user in this tenant. So why did we fall out of our chairs? Because that is evidence of Azure OAuth application exploitation in the small to medium businesses. And up until that point, we had not realized we had theories, we had hypotheses, we had academic papers and red team exercises and all manner of things that pointed to, yeah, application attacks exist, but we haven't really seen anything in the SMB. This research project was designed to uncover those application attacks in the SMB. And after we had gotten back up into our chairs, we then started to wonder, how many more of these are out there? Because that was one. And we can't really find these by looking for things called ... because they could be named anything, right? And they could have application permissions that do anything, right? So this was the genesis, and thus begins the presentation, When Apps Attack. And this is an exploration of hunting Traitorware and rogue Microsoft 365 apps in the small to medium business scale. My name is Matt Kiely. I'm joined by my colleague and co-pilot here, Christina Parry. Just a little bit about myself. I go by HuskyHacks in the community. I'm a communal practitioner. I work at Huntress in my day job, but at night I am anywhere the hackers are hanging out, I guess. And I'm an instructor at TCM Security Academy as well. Christina, please introduce yourself.
Yeah, so happy to be here. My name is Christina Parry. I am a staff ThreatOps developer at Huntress. Been there just over 2 years. I'm more on the blue teaming side. So at Huntress, I'm on a small but mighty dev team in our security department, and we build end-to-end POCs, capabilities, end-to-end solutions for our detection engineers, our threat intelligence team, and SOC. So super, and our product researchers, how could I forget? But this was a POC that came about really from our work organically. So yeah, excited to jump in.
Agenda today, we're going to talk about a crash course in Azure applications, just so we're all kind of working from the same sheet of music. If you're familiar with M365 and Azure, this is going to be kind of review. If you're not, hold on. We'll talk about the two types of tradecraft that are pertinent to hunting down this type of activity in the small to medium business. And then we're going to talk about, and that's all very like theoretical, that's the kind of red team academic exercises, but we're going to talk about the research itself and how we decided to take a nice big swing at answering the question, how many more of them are out there, right? So who is in a general sense familiar with like M365, Azure, how all that ecosystem works? I'm so sorry. I'm so sorry. If you're not, then settle down, kids, because it's time to talk about OAuth. Who has seen this before, though? I think more people have probably seen this before, right? This is what you see when in Microsoft 365, you are prompted to install some kind of application. When I say application, it really can be anything. I mean, people install Microsoft 365 applications to organize their calendars, to organize their emails, to sync up their login SSO to like Facebook or something like that. Just weird things. But I'd be willing to bet that like a lot of people don't even worry about the name of the app in that case, but just a lot of people are familiar with like the forward-facing, user-facing ecosystem. But this is a little bit about how that works in the back end, right? So Microsoft wants Azure to be very attractive for developers, right? Because they want apps developed on their Azure infrastructure. So we're all up in the cloud. We're developers. We're developing cloud applications that hook into Microsoft 365. And so these can be first-party applications that you build in-house for your own Microsoft tenant, right? These can be third-party applications that somebody else built that you want to access. But at the end of the day, all an app is, just like an app on the endpoint, is like a service of some kind. It's like it has access to a resource. It does a certain thing. Now, the interesting thing about the cloud instance and the cloud applications in Azure is that they hook into OAuth. OAuth, in a lot of ways, is like the Kerberos of the cloud. That is not a compliment when I say that. I'm not using that as a compliment. It's Kerberos for the cloud. We're going to go over. If that doesn't mean anything, you don't worry about. We're going to cover what that looks like here in a moment. What does this look like from a high level? Let's start with the end user, because we should always, in some form, start with the end user, because that's the person, the identity that is actually accessing a service, right? And so the end user might know of some application somewhere, right? And they want to use that application. They want to use it with Azure, with M365. Maybe it's like a calendar app or something like that. Now, they're going to live in their own tenant, right? So that's the HuskyWorks tenant. That's my testbed tenant. But just imagine that is their own home tenant, right? That application may have been built somewhere else. Maybe like Meta built it. Maybe it's built by some developer somewhere, right? So that lives somewhere else in some other tenant. Here is generally how this transaction goes. The user will try to find the application. Maybe they just Google for it. Maybe they get a link or something like that. And they say, hello, I'm a user and I'd like to install this application in my M365 tenant. And so the app is going to say something like, hello, we're going to just make one up here. I'm Email Buddy. This doesn't actually exist, but bear with me. I can help you organize and back up your emails, right? To do this, you'll need to install me in your tenant. You need to consent to all of the permissions that I require to operate, because I'm an application. So if you want me to do something on your behalf or to a resource that you control, I need permissions to be able to do that. I also need you to authenticate, and you need to delegate access so that I can access resources on your behalf. This makes sense, right? When we kind of rack and stack it like this, it kind of makes sense that like an application will have some kind of resource somewhere, and it needs to be able to access it as you. And it needs to have a certain set of permissions to be able to access that. And so, and as an aside, I use the Microsoft Graph API to do this. So the resource that I have to access is the Microsoft Graph API. Very straightforward, makes a lot of sense. Again, this is made up, but this is like a general pattern of how this works, right? And so the application in its own tenant will ask the user, all right, you can install me in your tenant. That's totally fine. But at the same time, do you also consent to the permissions that I will require to actually act on your behalf? And that's when that little description thing that says you consent to these permissions pops up, right? And the end user says, yep. And the reason the end user usually says yep is because by default in Azure, and this is an Azure specific most of this is general to like most cloud providers, but this is an Azure specific quirk that any user can install any application. And that's separate from the consent of permissions. Any user can consent to any permissions that are effective for their own assets. In other words, I cannot have an app as a low privilege user. I cannot install an app that has access to everybody's email inbox, but I can sure as heck install one that has access to mine, right? Again, by default. So the application in its own tenant says, great, let's perform the process of auth N and auth Z. And these are the terms that we use in OAuth, which are authorization and authentication and authorization, respectively. So it lands this thing called the service principal, right? So when you consent to these applications, a service principal is instantiated and created in your home application or your home tenant, right? What is a service principal, Matt? I'll tell you what a service principal is. A service principal is a little, I think of it like a little robot buddy. I don't know if that's like weird, but it's like a little robot account, right? And it says greetings because it's a robot. I'm an instance. I am an instance of Email Buddy. I'm an instance of the application that you just installed. You, the user who installed me, I can access resources on your behalf because that's what you have consented to. And now notice that there is now a global representation of the application object itself. Where it's being developed stays where it's being developed, but there is a clone, an instance, a service account for that particular application in the tenant of the user installing it, right? And now that application is authenticated. Somebody installed it and provided their credentials to install it. It's authorized. I've said, yes, you can access the certain OAuth permissions that are required to let you see my emails or back up my emails or something like that. And it is able to access the resource on the user's behalf, right? And so anytime the user wants to then use that application, there's some kind of like client, right? There's like a little program you install, right? And the client itself will then authenticate to the individual tenants to say, hey, am I good to actually be used in this tenant, right? It doesn't have carte blanche. It doesn't have like all accesses all the time. It still needs to check with the identity provider, which in this case is Azure. And Azure says, yes, you're authorized. You're an authorized user of Email Buddy in this tenant, which has been granted the following permissions. I've kept track of them. The service principal also keeps track of who can use this and which permissions that they have. So, and then of course the service principal says affirmative because it's a robot. And looks good. Here is a token. And that is the entire process, right? And once that app has that token, it's a refresh token. Once the app is in control of that token, it can then access resources, in this case, the Graph API, by passing that token to the Graph API. So that is a roll-up of the OAuth process for all the way from installation of the application to authentication to authorization to the actual use of a token that gets generated as a result of that. And now you're probably wondering, well, that works for when an app is developed somewhere else, but what happens when an app is developed in-house? Same exact thing. Install. Consent? Yes. Authorize, authenticate. Okay, here's your token. Anytime you want to use it, and then you can use that token against the resource, right? Now, I know that was a lot. So let's cover 3 very interesting and very important things that come as a result of this system. So notice how the application can either be built in-house if somebody develops it in-house for their own tenants, or it can be built in another tenant and then installed via a service principal in the home tenant of the user. It uses this entire system of authentication called OAuth, right? And that is everything from the installation of the application to the authorization and the authentication. Those are 2 different things. Basically, yes, I want you in this tenant, and yes, you can have access to these permissions, right? And that's all governed by Microsoft's implementation of OAuth in Azure. And these applications can either have delegated access to one user or many users, or in some cases, they can be installed as just an application itself, which services, it can be consented to service everything in the tenant. And like any system, and my callback to Kerberos in the cloud was not an accident, like any system that has sufficient complications to find lots of little cracks in the system, this makes it fantastic, a fantastic toolkit for exploitation, right? And so, I don't know, it might be a little hard to see that just because of the lights, but basically what that says is that an attacker can then either socially engineer, or they could install themselves, so they can have somebody install it on their behalf, or they could install it themselves if they have the accesses to it. It uses the built-in schema of authentication and exploitation. There are no CVEs here. This is not public-facing exploitation. This isn't some random one-off, like, hurl a packet at a server and then root, kind of like that. This is the actual system of authentication that cloud apps are using in Azure, right? And every pen tester knows what are the best exploits. Feature, not bug, right? Feature, not bug. And apps are in a lot of ways customizable because the system that apps are built in has to be customizable because apps need to do a lot of different things, right? So the application itself can be built to scope to a single user. It can scope to a lot of users. It can access emails. It can access calendars. There's lots of customizability here. And that's why this is a fantastic system of exploitation and one that had me scratching my head at the outset of this research project thinking, well, what's the limit here? Like, how far can this go, right? We're going to cover 2 specific examples of tradecraft that we're looking to combat at the small to medium business scale. So we understand a little bit about OAuth in a general sense, how apps are built in a general sense. These are the actual tradecraft items that follow in the footsteps because we're just using the system as intended, but we can make it work in certain ways as an attacker. So the first one, Traitorware, okay? Every app has a dark side. A little bit of a Jekyll and Hyde situation going on. So Traitorware, the closest analog that I could come up with to Traitorware is somewhere between RMM abuse, if you're familiar with that, lol bins, kind of, not exactly, because these don't necessarily exist by default. They have to be installed, but really some kind of bring your own tool, right? And so Traitorware applications are applications that have legitimate normal uses and are designed by legitimate developers, right, for some legitimate use. But like I said, every app has a dark side. And a client that allows you to sync all of your emails can be used to sync all of an identity's emails, right? Listen to what I'm saying. A client that can sync all emails can be used to sync all emails. And that's redundant for a reason, right? Because it just depends on the intention at that point. So that's the first class of application that we're looking to fight here. Classic example of this, I heard this mentioned in one of the earlier talks today as a telltale sign of business email compromise. This is something called EM Client. It is a client application. It can sync all your emails. It can sync all your inboxes, commonly used in financial fraud attacks. But this is that's like an actual website. You can just go and download and install this into your tenant. And that's a legitimate application, but 99.9% of the time we've seen it in the small to medium business it's used for a business email compromise, a financial fraud attack. And this is just going through that system of you install it, it requires credentials. So this is like it's like an authenticated attack, right? And then you consent to those permissions. I'm consenting to it from my global admin account in my testbed. And at that point, you are then able, with the client application, to use that token that gets generated and pass it against the resource that you want, except that's not you in that case. That's a threat actor in some capacity. Item number 2, OAuth consent grant attacks. Artisanal, handcrafted, farm-to-table evil applications, right? So a little bit of an Amogus situation going on here. With Traitorware, that's like the bring your own, that's like the lol bins, that's like the RMM abuse, some legitimate tool co-opted for some kind of evil use, like sysinternals used to like dump, the LSAS or something like that. This is the opposite. This is like custom made malware. This is like you took the hammer and the chisel and you made yourself like an evil application, right? And so this is when an attacker creates an application with no other purpose than to just wreak havoc, right? And that's why this is customizable, so you can create this to do anything you need it to do as an authenticated attacker at that point. So the interesting thing about this is that no two of these are going to be alike in any way. No name is going to be the same. At least with EM Client, we see it by name a lot of the time, and we know that it's usually used maliciously. Not the case here. This one's a lot harder to hunt for, right? So, want to see how to build one? It's actually not super interesting. It's exactly how you build any application in Azure, right? Makes sense. It's just building one with the permissions that you need to wreak some kind of havoc. You register an application. This one's called Nothing Sus, LOL. If you already have access to the tenant, you can install this as a single tenant application. So you can just scope it right to that tenant. If you are using it for initial access, you can make it a multi-tenant application and then coerce somebody to install it on your behalf. And then you get to ask the wonderful question, the red team question, the hacker question, what do I need to actually affect on target here? What do I need to be able to to have the desired outcome, right? And so, well, the Microsoft Graph is just a fantastic resource. I mean, if you have the right credentials, the Microsoft Graph will tell you anything you need to know about basically anybody in the tenant. So you can just go ham on the permissions, right? Grab the Microsoft Graph as a resource, and then set up your permissions any way that you need. If you need to access inbox rules, emails, there's permissions for that. You can add permissions if you have the sufficient admin requirements and can consent to them. You can add permissions that can add, modify, delete, change passwords of users. The sky is essentially the limit. Don't worry about the specifics here, but basically, like anything, you're building an application from the ground up. Anything that the is allowed by accessing like the Microsoft Graph, you can do essentially. You just need the actual permissions to be able to do it. And then beyond initial access, I mean, initial access is great, but how do we persist, right? And this is why I said this is like the most underappreciated method of either initial access and persistence, right? Because these apps stick around. They don't just like disappear after the campaign is done. There's really two examples here, but I'm just going to focus on the second one, which is you can just add a password to one of these applications. And so by adding a password to one of the applications, specifically the service principal of that application, you can then just authenticate as that application, right? And so what that means, that's tantamount to single factor authentication and persistence in the environment. So like no password change is gonna save you here, right? If a user has installed this application and the user changes their password, but you still have a password to the application itself, then that's effective single factor for persistence. And then it's as easy as authenticating as the service principal in that case. This is all like, don't worry about the specifics here, but basically this is just calling the Azure command line to authenticate to the Microsoft Graph. And then you can enumerate users, you can enumerate a user's inbox rules, you can stage an inbox rule. It doesn't matter where you go from there, but basically the sky is the limit, et cetera, et cetera. You get the idea. So in summary, before I hand it over to my colleague, Christina, we've got a problem, right? The SMB is getting pwned. It's our problem, right? We don't know the depth of how far this goes, right? We understand a little bit of the attack surface. We know that there are certain apps by name that we can look for that are usually used maliciously, but there is, if you take a step back from that, that is low on the pyramid of pain. If you consider the system at play here, there is an entire system of knobs and levers and doodads and all kinds of things that you can pull to make these things extremely dangerous and persistent and very, very stealthy. They're used for initial access and persistence, and some of them are legitimate apps being used, for evil purposes, and some of them are custom built from the ground up. There's a lot of customizability here. They're usually going to be flying under the radar. Some of them are a bit like Among Us, which is like an evil app blending in, so you got to find the imposter, but some of them are kind of like a crowbar. Like, you can't just say, like, every time you've ever seen a crowbar, it's evil, right? If you see a crowbar, like, opening a window, maybe you need more context, right? But if you see a crowbar like being used to open a window and somebody with a ski mask, like it's just, you can't just say like a crowbar in somebody's house is evil. That doesn't work like that, right? So that is a summary of the problem statement. And so when on the outset of this research project, that's essentially what I knew, but I needed to bring in somebody who had a really good idea of taking all of this data and wrangling it and assessing it and building systems that we could use to classify and understand it at scale. So that's how we level the playing field, right? Is by using data. So I'm going to kick it over to Christina because she's going to tell you how we leveled the playing field in this case.
Sweet. Thank you so much, Matt. I'm just gonna move that
Want me to do that?
fine. Or I got it. Okay, do that. Yeah. So I just kind of want to talk a bit more about, like you said, Matt, thanks for the intro, for leveling the playing field against threat actors and nefarious users in M365 apps. So what are we looking for? Actually, can you do this? To make it easier, I won't do this. Thanks.
Of course.
So what are we looking for? That gave a couple of examples of Traitorware and OAuth app attacks. So we do have a sense of the impact and attack vectors, but why do we care? For those who like statistics, there's about 20% of all categorized threats related to OAuth apps oops, sorry, I totally butchered that. Around 20% of sorry, I'm gonna take that back. Around 20% of all categorized threats relate to OAuth apps. There we go. Which is crazy. And that number is on the rise. So it's something that I know many of you work in M365 and Azure, but like this is something that, like you said, Matt, is really under the radar and really is like something we gotta hone in on. So at its like worst impact, we can work like things we have to worry about include malicious applications created in compromised credible tenants, and the attack kill chain can look something like this picture, just to give an example. But and I think you gave a great example earlier, Matt. So it can just really do a lot of damage. But this is just one example of the broader impact that attacks can occur at the SMB scale. And we're going to hone in on how we can identify these. So simple question with a less than simple answer. How do we find these attacks? We went into this proof of concept with a hypothesis, a couple ideas in mind, and we have a couple ideas of red flags that we want to look out for. First, we have prevalence. So we would like to identify what are the most and least common apps that we see in M365. Is there a common denominator or maybe apps with shared commonalities, similar permissions, similar service principals? Another thing that like might be able to take into consideration is like if the publisher is verified or not. Is that something we should be looking into? Next, we have permission scope, application permissions and scopes. So we would like to identify one, which apps have the most powerful permissions and where do we see these apps with those permissions? And then lastly, we have user persistence. So we would like to identify the potential attack surface once users have those permissions and how they can enable and persist through a network. So we'll revisit these ideas in a bit. This was kind of just like our hypothesis going into the proof of concept. And yeah, so first things first, where do we get this data from? I know you did a quick show of hands. I'm going to do another quick show of hands. Can you raise your hand if you are familiar with Microsoft's Graph API? Woo, okay, cool. So this was brand new to me coming into this POC. So a couple quick things. So the data that we're interested in is really users, applications, and service principals. And obviously those relationships. So tenants have many apps, therefore, and also many service principals, many users to a given tenant. And then of course, all the permissions that come with those. So there's a lot that we can really dive into here. And yeah. Go on. So how do we want to visualize this data? Obviously, we can pull in this data from Graph API, but how do we want to visualize it? So we wanted to use Elasticsearch or Elk Stack, if you guys are familiar, for easily searching and querying on various fields that we get from Graph API. And also if we wanted to use ESQL, which is kind of like Splunk's SPL language, like for wrangling data. So we thought that in like aggregations, we could possibly get some interesting analyses there. And also, like I said, prevalence and most and least common app seen. So that's where we could find Elk Stack super helpful. We also, like Matt kind of started us off in our talk earlier, using Neo4j to be able to identify and call out uncommon or unusual relationships across nodes. So like if we have apps, tenants, users, permissions as the nodes, and then we have those respective relationships, what things look a bit common or which things are literally going to have us falling out of our chairs. So that's to give you guys a bit of context there. And then in terms of the dev plan, like kind of scoping this out, we wanted to be able to build an end-to-end solution to be able to accomplish the following. Like I said, to test our hypotheses, fine, okay, like where are we seeing rogue apps? So first, we got, or I guess it's like step 0 really, getting the access token. So we have that so that we're able to query tenant data, but obviously get the tenant data. And then with that, then basically building up the ETL pipeline. So I mean, that was pretty straightforward. We used AWS for our environment. So like caching the data, we stored it in S3, bulk ingested it into Elasticsearch. So it was super speedy and multi-threaded ingestion to Neo4j. And then basically we had like 3 output methods to be able to leverage the data in Elasticsearch Neo4j, or as a zip file for ad hoc analyses. And this was basically all done in a Python data collection script. So yeah, this is all going on through there. And yeah, and then once we basically have that data, we're able to dive headfirst into Elasticsearch and Neo4j to see what interesting things we find. So I don't know how well you guys can see this, but this is just kind of an overview of the AWS infrastructure that we used for our implementation. As I mentioned in the previous slide, Python, we have a Python script for collecting our tenant data that runs in a dedicated EC2 instance because we did multi-thread that. So we just wanted like a beefy standalone instance to be able to operate that. We had a second EC2 instance for standing up the Elk stack and Neo4j and Docker containers. And then in AWS, we used S3 for caching previously seen tenants within whatever specified look-back date. So we weren't copying the same data over and over. Just to like give you guys an idea, like the tenant data that we were seeing for each tenant, it was like if you put it into like JSON output was like maybe like 2 megabytes. So it was like pretty sizable. So being able to like wrangle and work with that data and transform it so it best fits our proof of concept, that was really helpful to us. And like I said, we also did compressed tarball file after this ran, just so we can do some summary scripts and like ad hoc analyses, which I'll show in the subsequent slides. So speaking of data models, like I said, we start with a tenant or base, like if you think of a tenant basically being an entire document, but like I said, that's a lot of data. There's a one-to-many relationship between tenants to users, to service principals, and those respective permissions. So in order to do the data analyses and really digging into the data effectively for Elasticsearch and Neo4j, we basically had to normalize the data and distill it down as best we could. So, and by normalizing the data in basically breaking out the one-to-many relationships as best as possible, this gave us the ability to use it in Elasticsearch and Neo4j. And so this is for the user data model. And basically we have 3 data models for a single document. So like when we load it into Elasticsearch or Neo4j, the data looks something like this. We have for user data model, we have user ID, tenant ID, the type, which is one of those 3, as well as the attributes. And then we keep the user ID and tenant ID in the attributes as like a foreign key, and then display name, user principal name, so that we have that user information available. Similarly, for the application data model for a single document, this also ties in the object ID. So we have that unique identifier. We have the application ID and tenant ID. And then we also have display name, publisher domain, sign-in audience, password creds, resource accesses, and OAuth permission scopes. So by having this information, we can find anything that stands out to us, or some things that are maybe less common than others. And yeah, and okay. Next slide. One other thing I did want to call out too is this little table I have on the right, which is basically the breakdown of this type between service principal, users, and applications. By far, you'll see that we have the most service principals. This makes sense, and we see very few apps relatively because these are often, just blank for a sec. We see a lot more service principals than applications because there's so many of them. Like you said before, they're like the local instances or like the little like email buddy like robots and stuff. So like these are highly customized, and we see a lot of different variations of these since they're spun out from the apps themselves. And yeah. So what rogueacts did we find? So a couple of things. For Traitorware, we enumerate, or across the proof of concept, we enumerated 2,500 tenants for the sample data set that we used. And we found tenants with apps that have the potential to be exploited from Azure identity attacks, which is really concerning. And even more so in some cases, one identity from a tenant, some of them actually had multiple applications that we considered rogue apps. And some of them even have been lurking in their environments for some time. So like, big yikes. And also, side note, we did notify the partners where we noticed suspicious rogue apps in their environment. So all good there. But yeah, this is very much a needle in the haystack problem crossed with finding the imposter in our rogue apps. So I wanted to talk a little bit about the prevalence breakdown for each tenant, the number of applications we see, and the number of service principals we see. So this is kind of to give like a high-level view of the sample data that we were looking at. Prevalence tells us how common these apps or service principals are. In the top prevalence bracket, 90 to 100%, we actually don't see applications, and only a considerable amount of service providers, around 159. So interestingly, this is expected and safe to assume because these are common and legitimate across service level providers, given that they're in the highest prevalence. So seems fine. However, on the flip side, in the less than 1% prevalence bucket, we see significantly more apps and service principals. What does that tell us? So this tells us that tenants commonly have a lot of service principals. As it showed in the slide, I had a couple slides back for in Elasticsearch. We have a lot more service principals. So like think of all the services that you have in your M365 environment for email, OneDrive, Teams, and all of these really add up. However, there are significantly more service principals and applications unique to each tenant. And then when we take a high-level view of the total tenant scene, so that's like the lower table there, there are over 6,000, or yeah, we have over 2,500 total tenants analyzed, as I mentioned, over 6,000 applications analyzed, and over 14,000 service principals analyzed. When we break this down in the prevalence bucket, we see that 99% of apps fall into that less than 1% prevalence, i.e. they're uncommon, unique, and highly customized to that local instance running. And then greater than 91% of service principals were also seen in the less than 1% bucket as well. And yeah, it sure would be unfortunate if someone had very certain permissions granted through an app to escalate and do potential damage. This. So findings that we have, I just did this by having a quick aggregation in Elasticsearch by which apps we see the most often for a given tenant. So most of these shouldn't be surprising. They're mostly Microsoft-related apps and services in the ecosystem, like Microsoft To Do, SharePoint, P2P server, Microsoft Graph, reporting, approval management. Those seem pretty like to be expected. So in that high prevalence bracket, checks out, seems okay based on prevalence. So yeah. So I think we can safely say and attest that prevalence has been helpful for narrowing down the unknown unknowns that we have. So the most common ones we see in that high, like 90 to 100% prevalence bucket, that's helpful to give a sense of, okay, that looks okay, like common to be expected. And then for least common, mileage may vary on its own, but if you see maybe it has like a suspicious name, or like how you had the example of like, well, nothing sus, or something that stands out, that, or like an example of, oh, like blank name, like admin app or something, like that's definitely weird. So in the data that we collected, we could easily search and pivot by that. So yeah, that's basically what we got. And global prevalence gives us an idea of how common any given instance of an application is for SMBs. Couple that with the power of permissions and which service principals those permissions are effective for. I think this has been really helpful for identifying prevalence among rogue apps. Okay, so again, going back to OAuth app attacks and the breakdown of total service principals analyzed and total rare service principals identified, we're basically able to bring this down from like over 1 million service providers that we've analyzed to about 1% of them. And we can take this a little bit further with the following. So looking at app scopes and permissions, we can look for some of the following characteristics. One example is looking at if there are OAuth scopes that can be abused for the following, such as mailbox settings, if the user has read and write all access, or if the application has read write all access, and the scopes were granted for all principals in that tenant. This is an example of Microsoft has recommended TTP mapping. So like if you see this, this is something that could be potentially sus just based on the app permissions alone. Another example of this is having the permissions containing directory, read, write, all, that has broad impact and effectively grants global tenant admin perms, which is obviously bad. So these are just some examples of the global prevalence seen in the less than 1% of surveyed tenants. So for diving into some of the examples, I don't know how you guys can see this, but basically a couple apps, service principals that we see, they have unknown publishers. They have those permissions that I mentioned on the previous slide, directory, read, write all, files, read all. And some of these have, those combinations of them can be suspicious and potentially malicious, but many of them are hiding out in the wild. And if you had any of those specific permissions, like read write access, like you can do potential damage, like enumerate all users and go through like all mailboxes for broad impact. So those can be quite dangerous. And one of the columns that we call out here is the prevalence percentage. So that's on a 0 to 1 range, how prevalent some of these could be. So something like Couchdrop or our clone, those are things that by name alone sound sus, but when you also look at the permissions, unknown publisher, and the reason behind it, those are all quite concerning. And just kind of like a side note, one of the things that we found doing this as well was like, for if the publisher is unknown, is that necessarily like a bad thing, or like if it's unverified? There was a good ThreatOps article on, it could be bad, or it could, like there are ways where based on having directory read write all, sometimes a good thing, or sometimes it doesn't necessarily mean malicious intent, but it's also read write all for a directory. So with great power comes great responsibility. But yeah. And then findings. So we really, to test our hypothesis, the slide I had earlier, did we find instances of OAuth app attacks and Traitorware? The answer to that, yes. We got prevalence. So we were successfully able to identify most common apps and service principals in M365. We assigned prevalence percentages for more and less common apps. And again, like I said, publishers, like if it's verified or not, or we recognize it, that's also potentially an indicator. The second thing being application permissions and scopes. So we were able to identify certain permission subsets that were potentially, if in the wrong hands, could do a lot of damage, and some of those patterns seen for potentially malicious apps. And then if the attacker has that, then they're able to obtain user persistence as well, like say having global admin perms, and could be dangerous if in the wrong hands. So TLDR, to recap on all of this, rogue apps is really not a one-size-fits-all solution for the SMB, but this is taking steps towards identifying them and filtering those unknowns. So yeah, and this is really challenging because apps are widely customized and unique to each tenant. And it really is a needle in the haystack problem, but we can start to tease out apps with the ideas that we shared earlier that appear to be malicious. So we can use prevalence. We can, when it comes to permissions and scopes, we can restrict, or something I would recommend to you guys to take away would be to restrict app perms for users, apply principle of least privilege. I know that's common sense, but like this is really like devil in the details stuff. So really being able to have auditing and reviewing for this, super helpful. And then for user persistence, you can use some of the known TTPs out there, the Microsoft ones. MITRE has them as well. Could do risk scoring just to understand what specific methods attackers are applying to gain persistence through apps. So what should you do if you see rogue apps in the wild? Got something for you. Behold, rogue apps.
So like everybody's got like a library of TTPs at this point that kind of it transposes the idea of like a script, and then the script can be used evilly, right? So like Wallbass is a good example of that. Unprotect is another example of that. So this is ours, right? So Huntress is actually powering this now. So if you, and we need the community support, like this is a bigger problem than like I think any one shop or any one person can fix. This is brand new. And if you go to our GitHub repository,
or the QR code,
thank you, you'll find just a library, effectively, of different applications and their malicious uses, right? And this helps in the Traitorware use case, right? So if you know that EM client is commonly used in business email compromise attacks because you are an incident responder for identity attacks and you've seen it 100 times, hit us up. It's open source, open a PR. There's some instructions there. Let us know what you see out there. Like running down Traitorware is like, we know of the ones that we know about, but I know there are more ways that apps out there. Like I said, every app has a dark side. Maybe not every app, but yeah, if you know one, open a PR. We'd love to see it.
Let us know. Okay. And then just to kind of like wrap this up, limits, constraints, future work, limits, constraints, really time, the implementation of this from like start to end, not including putting together a presentation at all, but this was great for the first iteration. Like we scoped out and we conquered what we set out to do. But the scope of the tenant sample data that we have is roughly 10% of the data that we have visibility into. Part of why we only have 10% is we encountered some ETL bottlenecks, specifically around the Graph API and Neo4j for ingesting that data there. Like to give you an idea, it took about 1 week to load the data from Graph API, again, for various reasons, but we worked with what we got, the 2,500 plus tenants, and unfortunately didn't get to load all that data into Neo4j, so I feel like there will very well likely be a V2 of this with more interesting findings, really being able to delve into that data in Neo4j, but this really was setting ourselves up for further investigation and really being able to do this data analysis at scale. So looking ahead, like I said, look forward to a V2 in the works. And then maybe potentially tinkering around with the data model we have. Maybe we want to include more fields. Maybe if we want to transform it. Works for now, but again, when we scale this for like tens of thousands of tenants, I think there is like, the total is like over 26,000 tenants. So like,
that's a lot of nodes. That's a lot of nodes. That's a lot of documents. That's a lot of relationships.
Yeah. Like even for like Elasticsearch, like I did like bulk ingestion for that, and that was like very quick, but the scale of doing this at like tens of thousands of tenants, you need to be able to do this in an optimized way. So probably like we'll have to revamp Graph API using like async functions. And for Neo4j, we multi-threaded it, but like, again, needs more massaging in the ETL world, but super happy with what we have right now and we're able to share with you guys. So a couple of final takeaways for you guys. How can we safeguard against apps? Obviously, bit common sense, but NFA, 2FA, being able to make it more difficult for threat actors to get in the door in the first place. Secondly, no shadow IT. So normal users shouldn't be allowed to add new apps, ideally, and preemptively, admins can manage user content to apps in M365, so that can also be adjusted. And then, of course, reducing the attack surface, auditing apps on a routine basis, not removing unused apps.
Please.
Yeah.
If you listen to, if you don't take anything else away from this and you like run an M365 tenant, look at you can go into the Azure like dashboard. Please just audit your applications. Like you will find crazy stuff in there if knowing that your users can just install things like one-off whenever they want to. So please do that.
Yes. Please do. Also, don't over permission. Like I said, principle of least privilege. Common sense is not common, but trying to do our best and being able to look out for the 99%. Share what you know with the SMB community at large. And like I said, limited but increasing research exists in the malicious app space, but there's more we can do. And also, segue to rogue apps. So check us out. If you see malicious apps in your environment that you think other people are probably seeing, that would be awesome. And yeah, just to wrap up.
Yeah, for sure. Thanks to Dave on our team. He gave us the credential to be able to call the Graph API and collect all the data at scale. The irony is not lost on me that he gave me a password to an application that I then used to collect a whole bunch of information. And he said that was the most dangerous thing he's ever done in his career. So thank you, Dave. Thank you for the trust. And Sharon, of course, who used to work at Huntress, wrote a fantastic blog.
Was technically back at Huntress.
Wrote a fantastic blog about this as well. So thank you both.
Yeah.
And thank you for coming.
Thank you.
I think you have like 2 minutes for questions, probably.
Yeah.
Yes.
You had mentioned that 1/5 of attacks are on this vector. I'm wondering, is that the most prevalent attack on M365, or is there something greater?
I view it like in sectors. So like outside of the initial access and account takeover sector, that's where you're like rogue apps and your kind of like email inbox rules and stuff. Like, make no mistake, the bulk of attacks are account takeovers. That's like credential attacks. That's token theft. That's but this is like a sneakier, like this is a way to persist and gain initial access outside of that realm. There's really good defensive telemetry on token thefts and credential attacks and logging from VPNs and that kind of thing. I don't think there's as good telemetry over on the application side of the house. So is the most prevalent? No. Is it the most underappreciated? I still say yes.
Any other questions? I think we have like 2 minutes. Yes.
Would you say that data visualization is the key to finding the needle in the haystack?
I'll take this one. Yes and no. I think part of it's like knowing what to like look out for, like I said, and I think that's why I tried to emphasize in this presentation, having a hypothesis, like what are things that we think are potential red flags to look out for? And I mean, part of that's like common sense. Part of it's like having some sort of baseline. And that's where I think the prevalence is super useful as like a guiding light of, okay, these look probably fine. But if we see an app called Adam admin account, like app, like that's definitely a red flag and totally not something we saw in Neo4j. But then like, I think starting with like Elasticsearch and being able to like filter, pivot, do aggregations on data. And then it's like, okay, this looks weird. If we want to drill into this more, let's look into those relationships in Neo4j. So yeah, like I said, more to come on this. This was really just kind of like the setup of like the process and methodology and getting rogue apps out there. But I have a strong feeling there will be a part 2 for this.
That's all the time we have. So thank you so much.
Thank you so much.